So as we start our final exam material, hopefully some of these chapters, and certainly the digestive system, may be more familiar to you than the specifics of the nervous system. That's a complicated chapter, the nervous system and the sensory systems. So maybe digestive and the remaining two are going to be a little more straightforward. So what is the digestive system for? What's the function of the digestive system? Basically, to get the nutrients you need from your raw materials that we eat into the bloodstream and to your cells. So your digestive system is a conversion factory. It's a breakdown factory. I think I heard someone say breakdown. Because you're not going to absorb a Big Mac into your cells. That's not going to happen. But that Big Mac's going to have carbohydrates. It's going to have proteins. It's going to have fats. All of the important materials that you're going to need to find these nutrient byproducts to get into the body. Now, when we look at the digestive system, this is really the sort of principle in which you may hear some biologists say that the human body plan is a tube within a tube. Do you understand what we're talking about? Your digestive system is essentially a hollow tube. It's going to be open at the mouth, and the tube's going to extend all the way down, and it's going to open up at the other end. That's the tube. The outside tube is going to be your skin that completely wraps around your body, and that means we've got a lot of stuff in the middle as well. Well, our inside tube that makes up our digestive system, or a big component of it, is called the gastrointestinal tract, or the GI tract. Now, intestinal, the second part of that word, we've got that, right? Intestinal refers to what organs? Your intestines, straightforward. Gastro, what do you think gastro refers to? Gastric, your stomach. So here we're talking about, by and large, the stomach and the tube that gets food from our mouth to our stomach, as well as our intestinal tract. And in this illustration, this is showing the various components, not just of the tubular network of the digestive system, but also a couple of the important accessory digestive glands. So we start again in the oral cavity. Then we have our esophagus that's bringing our food down behind the heart. That's going to connect to our stomach. We can see our small and large intestines. It comes down to the rectum and it exits the body at the anus. Who can tell me what this brown thing is right here? Any guess? Oh, somebody got it. The liver. That's the liver. That's going to be an accessory digestive gland among the other functions of the liver. What about the little green dot? Gallbladder. That doesn't always work right. In fact, our biology secretary just had to have hers removed last week. You got yours removed 4 weeks ago? Oh, that's right. You did. Now, we can't see it, but there's a little hint of something right here at the end of the stomach before we move to the intestines. That's the pancreas. That's another digestive gland that we'll talk about. You really can't digest food completely without the enzymes coming from the pancreas. So what we saw in the picture here now is, think of it almost like a flow chart. If food enters the mouth, these are the different parts of the gastrointestinal tract that we're going to pass through from start to finish. And I'll just give you a few minutes to jot these down. And we're going to talk about each one of these parts. And again, is there any new information up here that you haven't been familiar with? I mean, pharynx, that's throat, right? Other than that, I think we're pretty familiar with this plan of our gastrointestinal tract. Ooh, that was loud. Now, I'm a picture person, and on this particular illustration, it's what we saw before, but it gives you not only the accessory glands, like salivary glands we see here, but also the function of these particular component parts. We see our GI tract on the right and our accessory glands, including the pancreas that we mentioned and the salivary glands, on the left. It's a nice summary slide as you begin to study and prepare for the final exam. And when are you going to start studying for the final exam? Very good answer. Good answer. So let's start talking about some of these components. And certainly, as food enters our mouth, our salivary glands are going to be the first to begin the process of chemical digestion, adding enzymes to our food to begin that process of breaking our material down. The liver is going to be producing bile. We're going to see that bile is an emulsifier of fats, meaning it breaks it down into smaller little droplets. That bile gets stored in the gallbladder before it's released into your intestines. And then our pancreas, this is almost like salivary glands, but just deeper in our body. It's going to produce very similar enzymes to what we see in our saliva. And that's going to finish off the process in our intestines. Now, this is a weird-looking picture. But what I want you to appreciate from this illustration is the generic structure of our GI tract. Whether we're talking about the esophagus or the stomach or your intestines or your rectum, it's going to follow this basic plan where we have an inside layer that's going to have its particular function. We're going to have a layer just outside. We're going to have a muscular layer that has muscle oriented in two different directions. And then we're going to have an outside wrapping. That's going to be the plan all the way down. We're going to modify it in different places. Okay? So if we look at these four generalized layers of our gastrointestinal tract, the one on the inside, this is called the mucosa. Now, in our stomach, the mucosa is going to be responsible for producing, among other things, hydrochloric acid. In the esophagus, our mucosa is going to be responsible in part to produce mucus to help lubricate the esophagus. In the intestines, the mucosa are going to be specialized cells that transports the good stuff like glucose out of the inside of our intestine, which is called the lumen, the hollow part, transport that material into the cells and then put it into the bloodstream. But what I want us to know here, mucosa, the inside layer of our gastrointestinal tract. Now we start on the inside, we work our way out. The next layer adjacent to the mucosa is called the submucosa. Isn't that cool? What does sub mean? Beneath, below. So this is the layer below the mucosa. Mostly connective tissue, but within this layer we're going to find blood vessels, lymphatic vessels, and it's great that we have lymphatic vessels because much of the nutrients that we pull out of the lumen by our intestinal cells, a lot of that material is going to get dumped into our lymphatic system, particularly the fats. But then we also have nerves that are going to let us know, okay, number one, what's going on? What are we sensing? How are we feeling? But we're also going to have a bunch of nerves that are going to help control the contraction of those muscular layers. The longitudinal layer that goes up and down and the circular layer that goes around. And we're going to see those functions as we go through. But as we were talking about the muscles, we can combine the circular and the longitudinal into the third layer that we call the muscularis layer. Big fancy name that just means the layer of muscle. Now, when we say muscle, are we talking about skeletal muscle? Is skeletal muscle going to make up the muscularis? Is it going to be cardiac muscle? What muscle is going to be wrapped around our GI tract? Smooth muscle, because smooth muscle is what? Do you have to think about it to process your food? It's involuntary. So that's why we have smooth muscle. And so the squeezing that happens, the shortening that happens, this is going to be a process called peristalsis. It's going to help move that material that you ate and are processing through your alimentary canal, but it's also going to be kneading. Do you know what I mean? Have you ever seen someone knead bread dough? You bunch it up and you punch it and you move it around and you push it and you twist it. That's what's happening to that material that you ate. And it's all because of the muscle layer, the smooth muscles arranged in basically those two patterns. And finally, we get to our outer layer. And this again is going to be connective tissue. And this connective tissue is called the serosa. Now, that name can change depending on if there's another membrane wrapped around you, but for our purposes in here, we're going to stick with serosa. Now, the last thing that I want to point out on this slide, and it's been sort of stuck up there this whole time, is this term called a sphincter. I want you to think of this sphincter as a valve or a gate. And in this case, the sphincter is going to be a muscular ring that can close off a passageway. You contract the muscle so tight, nothing's going to go past it. Or you relax that ring of muscle and open it up so now material can pass. We're going to have a couple of sphincters that we're going to talk about as we go through that's going to control and make sure food goes in one direction. And it's also going to make sure the food doesn't move until it's time, until it's ready. And that's just going to be expanded muscle of the muscularis that basically is shaped into a sphincter. So once again, we see the mucosa in our illustration. Now we've got our labels. The submucosa with our connective tissue, arteries, veins, blood vessels, lymphatics, and nerves. You can see our smooth muscle cells in the direction. There's the circular versus the longitudinal. And then our protective, connective outermost layer called the serosa. So we talked about the muscle. We talked about kneading the material, mechanical processing of the material. Now, I don't think anyone would have problems guessing. If we're talking about mechanical processing, mechanical digestion, where does that start in your digestive system? In your mouth. What structures are important for mechanical digestion? Your teeth. Your teeth are going to crunch, they're going to grind, they're going to break your food down into smaller and smaller pieces, which when you think of it scientifically, is simply increasing the surface area of all those food particles so you can get the enzymes and the acid completely to every inch. Because if you just had a whole Big Mac, the enzymes and the acid would only be able to act on the outside part. It would take a while to digest it down to the middle. But by taking bites and then grinding that bite up into smaller and smaller pieces, you make chemical digestion go much more rapidly and much more efficiently. Now there's another component of mechanical digestion that we usually don't think about until it goes wrong. Now, our teeth are critical for mechanical digestion in our mouth. But there's something else that's important for mechanical digestion because it undergoes and facilitates something called intraoral transport. What in your mouth facilitates intraoral transport for mechanical digestion? Your tongue. How do you know it's involved in eating when it goes wrong? Have you ever bitten your tongue while you're eating? That's because your tongue is moving the food back and forth between the teeth, up and down, so you're not just biting the same stuff in the same place, which wouldn't be an efficient way to grind the food. And when you bite your tongue while you're eating, do you just kind of give it a little love nibble? Or do you usually crunch down on that thing? Yeah. It hurts. It hurts. And so your teeth and your tongue are both involved in this process of mechanical digestion. Now, as we move down into our esophagus is where this process begins of peristalsis. This is where those smooth involuntary muscles take over. And so what we have is our circular smooth muscle clamping down like a sphincter. Okay? It clamps down behind the food particle. Now we take our longitudinal smooth muscle, and by the way, this pinching off with our circular smooth muscle, it may in fact divide some of that material in half, and that's called segmentation. It's like cutting it in half and just processing apart. But then what we're going to have is we're going to have our longitudinal smooth muscle shorten on a small segment of your esophagus or in your intestine. And when it shortens, it's going to move that food on this side of our circular muscle closer to this end. Then that circle of muscle is going to relax. Another circle of muscle is going to clamp down. And then as our longitudinal muscle relaxes, it's going to slide that food down. I know that's kind of hard to visualize, but you've all done something very similar. How many of you have a pair of sweatpants that's got the shoestring in it? Or have ever had sweatpants with the shoestring in it? Anybody? Who has not lost the shoestring inside the waistband? Has everybody done that? How do you get that sucker out? Huh?
The laundry machine.
The laundry? No. How do you get it threaded back through there? Okay, so you find the little end of the shoelace, right? It's called the aglet. You pinch it, right? That pinching is like our circular smooth muscle. Then you bunch up the material so that your other fingers grab the aglet. That's exactly what's happening with segmentation. Then with your first set of fingers, you relax that muscle and pull the material so the thread slides down. Have you ever done that? And you keep doing that? That's a perfect example of the two steps of peristalsis. The circular muscle pinching, the longitudinal muscle shorting, the circular muscle pinching here, and then that segment relaxing and sliding the string, in our case food, further down the alimentary canal. Does everyone see how that works? That's peristalsis. That's the muscular part of your esophagus, your stomach, your intestines, moving food all the way down. It's hard to visualize the process in a still two-dimensional picture. There are a number of great videos. If you go to YouTube, type in peristalsis, there'll be a number of great videos that are illustrating this pinching, sliding, pinching, sliding. But that's what they're trying to illustrate. With the pinching and the sliding is just an arrow. So that's not all that impressive, right? But do you see as you're undergoing peristalsis, this repeated pinching and sliding, do you see what's happening to your food particles? See, in our top illustration on the right, there's a fairly large food particle, and you've got the pinching and the sliding. But then it gets pinched in the middle. Now that food particle is reduced in half the size. And then we get reduced again and again and again. So that mechanical processing is not just the teeth. It's not just the tongue. But it's happening all along the length of your alimentary canal. And when I say alimentary canal, that's another word for GI tract. Okay? I just threw a different word in there. Alimentary canal, GI tract, it's talking about the same tube that we're processing. So we have mechanical processing that we've talked about, but the chemical digestion of your food happens because a number of secretions that are added in. And again, mechanical digestion started in your mouth. Where does chemical digestion start? in the mouth with your saliva. So it's all getting started in the same place. So your saliva is liquid that has enzymes. And again, as we move further down our digestive tract, we're going to be adding mucus, which partly is to lubricate the passageway, but it's also going to be protective in nature. And then we have bile and other secretions that we'll get to. But all of those chemicals are going to be added in to further reduce our raw materials into a very foundational basic unit that can be absorbed into our bloodstream. So we've got mechanical processing, we've got secretion, and if we put both of those together, guess what we have? Digestion. Digestion. That's what we're doing. Starting in our mouth, moving our food to our stomach, and even in the first part of our intestine, this is where digestion is taking place. So one of the chief functions of our gastrointestinal tract is, in fact, digestion. But after we get past the first part of our small intestine, the bulk of our small intestine, our large intestine, its number one function is no longer digestion. We're no longer breaking material down. Now we're undergoing the process of absorption. Absorption is where you take those materials that have been broken down and you transport them into our circulatory system, either our bloodstream or our lymphatic system. So if we talk about the principal functions of the digestive system, it's going to be both digestion and absorption. Because does it do your body any good if you digest everything but don't absorb it? No. Does that ever happen to us? You betcha. That's called diarrhea. It just floods out. You don't have a chance to absorb it. And we're going to talk about some of those instances where we have problems in our digestive system. And we talk about diarrhea, we kind of giggle about it. It's no fun. It's really nasty. But there are people in the world, and I think maybe about 10,000 people a year die from diarrhea. They die from, can you think of a worse way to go? You diarrhea yourself to death. It's because they have contaminated water and it has parasites in it. And when you have diarrhea, your intestines go, you know what, we're not going to absorb all this water. We're going to turn on water pumps and try to flush this nasty stuff out of our system. And so you don't absorb the material, but you dehydrate yourself really quickly too. So the people usually die from malnutrition and dehydration. And clean water would be what would save their lives. But they don't have clean water. Speaking of diarrhea, the final part of the digestive system, elimination. Your waste products, you've got to get rid of it. And much like in our urinary system, which I believe we'll talk about in one of the other two units, the digestive system, controlling elimination is a learned process, is it not? When you have a baby, you'll realize they're not born asking permission to go to the bathroom. No, babies go to the bathroom when? Whenever they feel like it. You have to learn potty training. And in fact, I'm not sure if we're going to get into the details yet, but at the lower part of your rectum, there are two sphincters. The one on the inside is smooth muscle. What does that mean? Involuntary. The one on the outside is part of your peritoneum. It's skeletal muscle. What is that? Voluntary. But guess what? If your bowels and your rectum are so full, there is a reflex to keep you from bursting your rectum. So guess what's going to happen whether you want it to or not? It's going to come out. And it's the same with your bladder. Has anyone ever been on vacation and dad's trying to make time and you got to go, but no, we're this, and then they hit like a pothole or a railroad track, and yeah, same sort of thing in both systems. All right, so let's start at the top and work our way down. In the mouth, where we have our teeth and our tongue, we don't spend a lot of time talking about the tongue, but I wanted to make you aware of that. Mechanical digestion begins when we're kids. We have 20 teeth. As adults, we're going to have in the neighborhood of 32. That's counting your wisdom teeth. Now, another big fancy name for our, we don't say kid teeth, what do we say? Baby teeth, are deciduous teeth. If you ever take a class on botany, plants, you're going to hear that term deciduous. Deciduous plants are plants that lose their leaves in the fall. These are deciduous teeth because what's going to happen to them? They're going to fall out. And they're going to be replaced by our adult teeth. In our adult teeth, we have the cutters on the front called incisors. We have our canines. We have one on each side, two in our lower jaw, one in our upper jaw. Oops, backward, lower, upper. What's another way we refer to our canines? Especially at Halloween. Fangs. Yeah, your canines are your fangs. And then we have our premolars, and then we finally have our molars, with our wisdom teeth being in the very back. Yeah?
Okay. Is it possible for you to have way less teeth with 32?
Well, again, if you have had your wisdom teeth either cut out or if they haven't come in yet.
Have your wisdom teeth enough?
Yeah, if you haven't had your wisdom teeth, then you're missing 4. So we would be in the neighborhood of 28.
I'm missing 8.
You're missing 8?
I don't have 24 teeth.
Did you just count them?
Yeah.
We'll talk. Yeah, she's okay. She's fine. Yeah, she's fine. Both my daughter, that's a sophomore, and I both had 5 wisdom teeth. One looked like a baby tooth that just didn't finish erupting. It was underneath the gums. So maybe we got the extra you're missing ones. Now, as far as your teeth go, the structure of a tooth is going to have the crown. That's what we see, our pearly whites, and the root. That's the part that's embedded down into the gum line. And although we can look at the white of our tooth and realize that material is pretty hard, right? Are your teeth hard? Yeah. Bones are white, bones are hard, but understand bone and your teeth are not the same stuff. They're still made of calcium, they're still made of phosphorus. But the white of our teeth is not bone, it is a substance called enamel. And notice this second word here. What is that? Non-living. It is a hard acellular layer. And since enamel is not living, can you regrow enamel? No. Your adult teeth, the teeth you have right now, they've got to last you a lifetime. So you got to take care of them. So the outside layer is called enamel. The inside layer, and actually on the inside we sort of have, you know how your bones, you have the bone marrow? Kind of that spongy inside layer. On the inside layer of our teeth we have what's called the pulp cavity. It's where we got blood vessels and nerves running. And lining that pulp cavity, so the inside actual layer, is called the dentin. This is where we have a living layer. This is going to be similar to what we have with bone. This is just a fairly solid, it has some pores in it. And if you have a lot of pores in it, anybody have really sensitive teeth to cold? Okay, if you have real sensitive teeth to cold, you have a lot more pores in your enamel that allows that cold to get down to the dentin and to your nerves a lot quicker. So here we can see in our illustration this sort of gray part out on the outside. That's our crown. There's our enamel. They always draw this with lines in it. Kind of like in our bone, how we had those little lines interconnecting all those cells. That's going to be representative of that living dentin layer. And then on the inside, our blood vessels, nerves, That's going to be our pulp cavity. And then there's the root that's anchored down into the bone of your jaws. That's why they usually don't come out very easily. Now, you've got some of these other terms in here. We're not going to worry about those, just the ones on that previous slide. Okay. Oh, there's the tongue. So, with our tongue, intraoral transport, I think that was the fancy terms I used. It just moves your food around. Positioning that material so you can mechanically digest it best. And in fact, if you had to describe what is your tongue, if an alien landed and was asking you about your body parts, then they said, what is your tongue? It's a muscular organ. But the muscles in your tongue, they're arranged in about 5 different orientations. So it's not just like one big muscle that just does one thing. And in fact, okay, who can do the clover? Who can do the clover leaf? I can just curl mine. That's all I can do. You got the clover? How many leaves? Okay, she's got 3 leaves. Anybody? There's a picture online of somebody that can do 5. 5 ruffles. You know what I'm talking about? And that's sort of indicative of the different muscles in the arrangement. I think we all have the capacity to do that, or maybe not. Who can't curl their tongue? You know the little jelly roll, you can't curl your tongue? It's genetic. You can't curl your tongue? Kind of ish. My poor middle daughter, she was the only one of my 3 daughters that couldn't curl their tongues. So when my other 2 were mad at her, what would they do? They would stick their tongue out at her with a curl, and she would start crying because she couldn't curl her tongue. This is when she was little bitty. So the muscular tongue is important in mechanical digestion. So as long as we've got our food in our mouth, we have to continue because now we're going to add the chemicals to it, right? And this lovely chemical that we call spit, saliva, what is that going to do? Well, it's going to moisten the food that we just ate. We're going to add enzymes that are going to start breaking down the material at the molecular level. Mucus for lubrication. But in our saliva, we also have lysozyme. Lysozyme is an enzyme not for breaking down food. Lysozyme is an antibacterial. So it inhibits or literally kills bacterial growth. And it's a good thing because we don't always brush our teeth twice a day, do we? Even though we should. Okay, who brushes their teeth twice a day? Anybody going to admit you brush? Okay, keep hands up. No, raise them up real high. Raise them up real high. Okay, I got one more question for you. Okay, how many of you floss every day? Oh, did you do? The hands dropped like a rock. Every time I go to the dentist, they go, "Oh, your teeth look really good. How often do you floss?" I'm like, "Man, it's hot outside." How often do you floss? I'm sorry, what did you say? My hearing is kind of, that's the good thing about being old. You can fake being deaf, right? Just lie? What did you say? Just lie? They can see the stuff.
My dentist told me I didn't have to floss every day.
You what?
They said,
Has anyone ever had a dentist that said you don't have to floss every day? No, I think they get kickbacks from the flossing company.
my dentist thinks I floss with my next teeth. I've never had a cavity or anything.
You've never had, I'm not talking to you.
My grandfather didn't have much teeth.
Are you kidding me?
It's a tooth.
Wow. So, thankfully, I've got saliva because clearly I should be flossing and brushing a lot more than I do. But this is a cross-section through the human face showing our upper and lower jaw. And 3, these are our major salivary glands. We have the sublingual gland. Anyone tell me where that is based on the name? Below the tongue. Lingual is tongue. Oh, this is an easy one. Submandibular. Below the mandible. Lower jaw is the mandible. So you can see this one's right next to the tongue. This is down below. And the parotid gland is over here on the side of your face. Now, can you think of a disease that affects the parotid gland? And this sometimes happens in kids, knowing that it's right back here. Huh? Mm-mm. Causes them to get their parotid to get inflamed. And you get these big bumps on either side back here. I don't think that we have much of a problem with it anymore, but it is making a comeback because parents are choosing not to vaccinate their kids. The mumps. I mean, has anyone ever heard or seen of anybody with the mumps anymore? But you get these really swollen parotid glands on either side, these big chipmunk cheeks back here. That's the mumps because that's what gets infected. Well, I think like most, I believe it's a viral disease. I mean, it's not pleasant to have. Treated pretty quickly. It's not, deadly, but it is highly contagious. And that's the thing about, getting, what is it, the MMR, measles, mumps, rubella, is that the vaccine to give to kids? That's why it's important. If your kids are in schools and around other kids, man, make sure your kids are vaccinated because more and more children aren't. And that's a personal choice the parents have. But then we also get into the arena of like, well, yeah, but my kids are put at more risk. And so it's not an easy answer, okay? It's not an easy answer when it comes to vaccines and children and all that. All right, so we're chewing our food, tongue moving it around, saliva's breaking it down. Now, because of our tongue, we don't, have you ever been eating and you go, you know what, I'm swallowing my food, but I'm not really thinking about it. I'm just talking and eating and it just goes down. So your tongue is going to be involved in somewhat of the involuntary aspect of moving your food to the back of your throat, the pharynx. And then because of that little cartilage flap that goes over our trachea, remember what we call that? The epiglottis. It's going to create a ramp that once the food gets to the back of our throat and our pharynx, that ramp is going to direct it right into our esophagus. And our esophagus, especially the top part of our esophagus, is going to be more skeletal muscle wrapped around it. Skeletal muscle, voluntary or involuntary? Voluntary. Because there's some instances when you want to swallow. It's not an involuntary process. Swallowing a pill. Do you remember learning to swallow a pill, how difficult that was at first? Okay? It was difficult for me until I learned a trick because I don't like the taste of a lot of those pills. You put them on your tongue and before you can take a drink, it's just nasty. So I would fill my mouth with water, tilt my head back because I didn't like the taste, drop the pill in. Now you're stuck, right? You got to swallow. And that swallow is voluntary. So the upper part of your esophagus, you control the initiation of the swallow. But as you move down your esophagus, that skeletal muscle is switched out for smooth muscle so that by the time you get to the bottom 1/3 of your esophagus, all the muscle is smooth muscle. So once you start the voluntary part of a swallow, the rest is involuntary and part of what's called the swallowing reflex. And you've probably learned this the hard way too, right? Have you ever been able to stop a swallow after you start it? I mean, on purpose? Have you ever been eating and someone say something really funny? Or, yeah, then it's like everything goes in reverse and it comes out your nose and your ears and everything else? Yeah. You can't really stop a swallow once it gets started because it's taken over by your involuntary smooth muscle as part of the swallowing reflex. So again, just an illustration. I don't know. Do you think that's a pickle? I don't know. I've often wondered, what is this guy eating? Celery? It just says bolus of food. A bolus of food means a chunk of partially digested material. But it kind of looks like a pickle. We'll say pickle. All right? So swallowing begins. Muscles are kept closed until we get to the involuntary phase and we start down the esophagus. Epiglottis closes off the trachea, opens the esophagus, and the food slides right down. So again, it's hard to see that in a static two-dimensional illustration. Again, I would encourage you to find some of those videos on YouTube that are really going to put this in motion and help you better understand it, especially peristalsis and how food moves down our esophagus. So now we're in the tubular part, right? We're out of the mouth in the tube, that's our GI tract. Our circular muscle, our longitudinal muscle, starts this process of conveying material down the esophagus to the stomach. And where the stomach connects to the esophagus, we have another circular band of muscle, another sphincter, and this is called the lower esophageal sphincter. That sphincter opens to allow food to move from the esophagus into the stomach. Now, is that a big problem? Is it a big problem wanting to make sure that food doesn't get into the stomach before it's ready? So if we have this sphincter, what do you think its job really is? If it's closed, yeah, nothing's going to get from the esophagus to the stomach, but that's not a big deal. What is this sphincter really doing? It's keeping stuff in your stomach from going backwards. Principally, what is in your stomach that you don't want to get into the esophagus? Acid. And what's a big clinical problem that we have these days with a lot of folks? Acid reflux. That lower esophageal sphincter isn't doing its job. It stays open. You get too much acid, goes straight up your esophagus, and you have what? Heartburn. It's got nothing to do with your heart, but the esophagus runs right behind your heart. And so that hurting in this area, that burning, that's why it's called heartburn. Does anyone have heartburn, especially at night? Okay, old people typically are the ones who have heartburn. If you eat right before you go to bed, that's probably indigestion. Some people will call it that. One way you can somewhat try to minimize that is how you lay in the bed. Your stomach curves around to your left side, typically. And so if you sleep on your left side, the acid will pool in that big curve of your stomach and not come up into your esophagus as much. But if you sleep on your right side, there's really no place for the acid to go except right into the esophagus, and that's when you'll get the heartburn. So that's one way you can kind of do that. Elevating your pillow a little bit so you're sitting up, that will also help keep any of the acid in your stomach. And there's just a little statement there about our acid reflux. Now, the other part of acid reflux, if you continue to get that acid in your esophagus is going to undergo inflammation. It's going to be irritated. It's going to swell up. And that lower part of your esophagus, where your lower esophageal sphincter is, it's going through a hole in your diaphragm that's called the hiatus of the diaphragm. Now that hole is to allow the esophagus and only the esophagus to pass through to the stomach. But as that esophagus expands, it's going to stretch that hiatus. It's going to stretch that hole. And so if your esophagus ever gets any relief and it shrinks, that hole's still going to be all stretched out, like the old waistband of your underwear, you know, the ones you like but won't stay up. And so that muscle of the diaphragm helps support that lower esophageal sphincter. And if you continue to stretch it so that it doesn't rebound, that's also going to be a problem with keeping that lower esophageal sphincter working properly. And if that gets stretched out too much, portions of your stomach may protrude up through that hole into your area where your lungs and your heart are. Have you ever heard of a hiatal hernia? That's your stomach coming up through the hiatus. And typically people that have acid reflux severely have a hiatal hernia, and they also have problems with their lower esophageal sphincter. So there are various surgical procedures that they can do, but not the least of which is pushing the stomach back down through the hiatus, securing the hiatus as a smaller hole so the stomach can't get back up in there. And there are other ways, kind of interesting ways to do that, in addition to those things, that will help with severe acid reflux. Again, this is just an illustration. We saw this before, but do you see right here at the base of the esophagus, that sort of enlarged two peaks pointing at each other? That's the lower esophageal sphincter. That has to open to let this food get in, but it stays closed to keep the acid from getting back into the esophagus. All right, so we're a bolus of food. We made it down the esophagus. Now we get past our lower esophageal sphincter and we're in the stomach. I am amazed, especially, is that on the 4th of July when they have the hot dog eating contest of Coney Island? I am amazed that someone can eat that many hot dogs and buns that fast. Because I think, what is the record, like 60 or 70 something hot dogs? I mean, it's a crazy number. The human stomach can hold 1 to 3 liters, but that's a whole lot more than that. And don't think you are going to start right now and go eat that many hot dogs, because you could actually burst the lining of your stomach. They have to stretch their stomach and stretch their stomach. And actually, I know it sounds weird. Oh, I've got to train to be a competitive eater, but you literally do. Because you have to train your stomach to accept that much that fast and to be able to stretch. So our stomach stores food while it is being digested. Now remember, digested, mechanical digestion. The stomach is muscular bag. It's going to just need that food. But the mucosa of the stomach is also going to produce hydrochloric acid, as well as certain enzymes that are going to begin to break down material in the food inside your stomach. Your stomach also has a sphincter at the very bottom of the stomach that's going to regulate when the food can pass from the stomach into the small intestine. The bottom of the stomach is called the pylorus, so this is called the pyloric sphincter. Now, another enzyme that's kind of interesting that your stomach produces, because when you're first born, what's your principal source of nutrition? Milk. Milk. It's a liquid. Liquid typically just flows right through your stomach into your intestine and keeps going. But milk is not water. Milk has got protein in it. And you need to chemically start the process of digesting protein in your stomach. If that just gets to your intestines, it's too complex of a molecular structure to absorb efficiently into your intestines. So there's an enzyme that your stomach produces called renin. Renin is important in making cheese. Because when you add renin to milk, what becomes of the milk? It curdles. Now, we think of curdled milk as rotten milk, okay? The enzyme begins to break down the proteins in the milk. Those proteins denature and they start to get all tangled up, and the milk proteins become solid clumps. The curds, okay, what's that? Little Miss Muffet eating her curds and whey. The curds, it's like cottage cheese, that's curds. But it leaves the liquid part that doesn't have a lot of protein left in it. It speeds through the stomach, but those curds stay in the stomach longer to continue the process of chemical breakdown. So you see how that enzyme renin was important? So when people wanted to make butter or wanted to make cheese, they had to put their milk in not the sheep's skins, but the stomachs of animals, because that stomach still produced the renin, still had renin in it. If they had an old skin, it wouldn't make the cheese because it didn't have the renin left. So that's the chemical process of digestion. Now, I mentioned some of those things, but these are the principal components of those secretions from the stomach, which we call gastric juice. Hydrochloric acid. You can denature proteins by dropping the pH. Hydrochloric acid, I think its pH is around 1 or 2. Very acidic. Now, we're also going to be putting in extra fluids and mucus. This is going to be for lubrication. And the mucus at the bottom of the stomach, before we move into the small intestine, it's going to have sodium bicarbonate to neutralize the acid, because we don't want the acid to get to our intestines because it would damage our intestines. But here's another enzyme, pepsinogen. But this is an inactive form. The active form of the enzyme is called pepsin. Pepsin is another protein digesting enzyme. Renin digests proteins, especially milk proteins. Pepsin is going to be a generic. It doesn't care what protein it is. It's going to start breaking down the proteins so we can then absorb the amino acids, the building blocks of our proteins. So here, if we look at our stomach, here's that curve that I was kind of talking about on the left side of your body. This is called the greater curvature of the stomach. This is the lesser curvature. And as we look at our little inset and we look at the layers of our stomach, you remember our 4 layers? There's our mucosa. Look how thick our mucosa is. It's so thick in the stomach because it's secreting so much material. Then we have our submucosa with our blood vessels and our nerves. We have our muscularis layer that actually has a couple of different directions. It's not just circular and longitudinal muscle. We have some oblique that's sort of off at a different angle to help with that kneading of our material. And then we get down to the bottom where we have our connective tissue serosa at the very bottom. Then if we looked at the very top of our mucosa, here's a little hole that goes down in what's called a gastric gland. If you were in the stomach looking at the wall of the stomach, it would look like Swiss cheese. All these little holes. They go down in these pits where we have the cells that are producing acid. Then at the very bottom, we have some cells that are producing our enzymes. These acid-producing cells, this is a freebie. Acid-producing cells are called parietal cells, and the enzyme-producing cells at the bottom are called chief cells. But they're producing both, and here's our mucus secreting cells that actually are secreting mucus that coats the surface of the stomach and the lining of the stomach. And that mucus has bicarbonate in it so that the acid we make doesn't digest our own stomach. Without that bicarbonate in the mucus, that acid would destroy our stomach. And in some cases it does that anyway, right? When the acid starts to break down places in your stomach, what do you have? An ulcer. A gastric ulcer. So, well, here we go, talking about just what I was mentioning. Mucus protects the lining from the acid. And if you have a sore in which you have begun to let that acid get down to that submucosal layer, where we have nerves and blood vessels, it's very painful. Then what we're going to have in our stomach is a peptic ulcer. And a lot of times when you start that process, the bacteria that live in your stomach, called H. pylori, they're going to get in that ulceration and it's not going to heal effectively. And for years and years, I think even decades, pharmaceutical companies knew that you could cure ulcers in stomach with antibiotics that are cheap. But the pharmaceutical companies wouldn't tell anyone because they wanted them to buy their ulcer medication that was a lot more expensive. That wasn't nearly as effective as antibiotics. But now we clearly know if you've got an ulcer, and there are various tests for H. pylori in your stomach. One is actually a breath test. You can drink this liquid, and if you have a lot of H. pylori in your gastrointestinal tract, it's going to cause you to produce more CO2, and as you breathe that out, because bacteria undergo fermentation, as you breathe that out, you can measure the CO2 level to know, do I have too many H. pylori populating my stomach? You need some, and we need the good bacteria in our stomach as well, but not as many as we see in a lot of patients. So do you see our 4 layers here? Mucosa, submucosa, muscularis, and the serosa. That's the ulcer. It gets down to where we have our nerves. That's where we have the H. pylori taking up shop after our acid sort of has eroded this area. And that's what antibiotics will aid in the process of allowing that to heal on its own by getting the bacteria out of that ulceration. But it's not really going to be all that pleasant until you get that sore healed up, because the acid's going to continue to impact on that spot. So we made it into the stomach. We've added all of the acid, the fluids, the gastric juice, the mucus. Now we need to get to the small intestine. And that passage from the stomach to the small intestine is our pyloric sphincter. Now notice, in the stomach we have partially digested material. We haven't finished chemical digestion just yet. Most of it happens in the stomach. But the rest of it is going to happen in the first part of our small intestine. Now, with all those layers in the stomach, the circular, the longitudinal, the oblique muscles, it may take 2 to 6 hours of your stomach churning this material, mixing it with the gastric juice, before it's appropriately digested enough to then make it past the pyloric sphincter to then enter your intestines to finish chemical digestion and to start the process of absorption. That seems like a long time. This is one reason why they say you should not eat 3 hours before you go to sleep at night. You need to finish eating, spend that 3 hours, and then go to sleep, because most of your material is in fact going to be digested before that 3 hours is up, but some may take as long as 6. And if you have a lot of material on your stomach when you go to sleep, your body is going to absorb every last little bit. And you're not burning it, so it's going to store it. So an easy way to lose weight is just don't eat before you go to bed. But there's something about 11, 12 o'clock at night that I don't know, that chocolate cake or Pop-Tarts. Anybody have a problem with Pop-Tarts in the middle of the night? What the heck is it? Are they filled with crack? I don't know. I wake up and I'm just like, I've got to have a Pop-Tart. And I don't care what flavor Pop-Tart. If there's a Pop-Tart in my house, I'm going to find that Pop-Tart. But it's not good for you. It's not healthy. Because our parasympathetic nervous system takes over when we sleep. And what is parasympathetic? Parasympathetic? What and what? Rest and digest. Now we know we could add rest, digest, and absorb. That's the part that's going on with our parasympathetic nervous system. Now again, drive the point home as much as possible. The stomach is digestion. It is not absorption. That's only going to take place and only going to happen in our intestines. So again, this is showing food entering past the lower esophageal sphincter. The red line is our bolus of food. Here the artist is trying to illustrate the constriction of our muscles, squeezing food down to the bottom. This is the pyloric region of the stomach. There, you see those little knobs? That's our pyloric sphincter at the bottom. Food gets down here. Some of the food is able to make it past the pyloric sphincter, but other portions of the food, if it's not digested appropriately, it goes back up and it starts to do it again. You ever seen a butter churn? Going up and down and up and down. Your stomach just moves food up and down and up and down and all around and crunching it and grinding it and kneading it until it's able to pass the pyloric sphincter and make its way into the intestines.